So right now you're going to be learning about force. Please make sure you have the force notes printed up in front of you, or if you're not printing them up, just have a piece of paper ready to write things down. After this PowerPoint and your note taking, you're going to take a little breather and then come back and do the one on Newton's second law of motion. This one will have Newton's first law of motion at the end of it. So here we go. Force. What is a force? A force is any push or pull on an object. There are two forces acting on you right now. Gravity is pulling you down. Whatever you're sitting on, chair, bed, floor, whatever, is pushing you back up. Force. All right, we measure forces, as you know from all the unit quizzes we used to take, with a unit called the Newton. I need you to define what a Newton is. A Newton is 1 kilogram times meters per second squared. That's the unit for Newtons, right there. What does that unit even mean? It means that 1 Newton of force is enough force to give 1 kilogram of mass an acceleration of 1 meter per second squared. If you want 2 kilograms to accelerate 1 meter per second squared, you got to have 2 Newtons of force, etc., etc. We'll get into that later on. That's Newton's second law. Let's get on with force and Newton's first law, shall we? Forces have directions to them. If I choose right to be positive, then left becomes negative. Any forces pushing or pulling to the left will be negative forces. It does not mean that they are less than the positive forces. Example. If I have a force of 3 newtons going that way, then 3 newtons going the other way would be negative 3 newtons. They're not less than. The negative 3 is not less than positive 3. It's the same amount of force, just in the other direction. So we call it negative. That helps us do math later on. Negative force only means the force is in the negative direction. It does not mean it's less. Can I say that more times? I don't think so. Okay, if you printed out the notes, flip them over to the back because there's no room for this on the front. I'm going to add a couple terms. First term I'm going to add is net force. The sum of all forces acting on an object. Pause now for you two to write that down, then start it back up again. Net force is not some sort of internet police force. No. There's a definition. You've already written it down. What if all the forces acting on you add up to 0, like is going on right now on your body? You're not accelerating. There's gravity pulling you down. There's the force of whatever you're sitting on pushing you up. Those two forces balance out. So the net force acting on you is 0. If it wasn't, you'd be accelerating. That situation where all the forces adding up on you add up to 0 is called balanced force. It seems like a very special thing, but really we experience it all the time. Anytime you're not moving, you're not accelerating, you've got a balanced force. Condition where all forces acting on an object add up to 0. Pause if you need to, finish writing it down, then come back. Okay, let's do a problem, shall we? I have a box with a force of 20 newtons pushing to the east and a force of 30 newtons pushing it to the west. What is the net force on the box and in which direction is it going? It would help if you could draw this out. Draw a little box. Have 20 newtons pushing it to the east. East is normally to the right. So draw a little arrow going to the east and put 20 newtons on top of it. Then draw another arrow going to the west and write 30 newtons on top of that. Pick one of those two directions to be positive. It doesn't matter. I'm going to say east is positive for now. So if east is positive, the 20 newtons is east. It is positive, sorry. And the 30 newtons is negative because it's going to the west. If you add those two up, 20 plus negative 30, it's the same thing as 20 minus 30. So you get negative 10 as your answer. Which way was negative? West. So the answer is 10 newtons west. Flip it. Let's say east is negative and west is positive, and you add them together. The 20 becomes negative, the 30 becomes positive. It's negative 20 plus 30. which is positive 10, but in this circumstance we made positive the west direction. So again, it's 10 newtons west. No matter which one you make positive, you're going to get the right answer, as long as you translate that positive negative sign back into directions after you're done. If you need to go back and review that again, by all means do it. In the meantime, we'll go on to the next problem. I have a rock being pushed up with a force of 37 newtons, and at the same time is being pushed down with a force of 44 newtons. What is the net force on the rock and in which direction? Alright, choose which one you want to be positive. It doesn't matter. You're going to have one of those is positive, the other one is negative. The difference between 37 and 44 is what? 7. So let's say up is positive. It would be 37 plus negative 44, which is negative 7. Negative was down if up was positive, so it's 7 newtons down. Flip the positive negative, you'll get the same answer, 7 newtons down. Alrighty then. Last problem. You and your friend are pushing a box. You exert a force of 27 newtons to the east, and your friend exerts a force of 30 newtons to the east. What is the net force on the box and in what direction? Pause, figure it out, and come back and check the answer. Oh, you're back. Good. So, hopefully you figured out that both you and your friend are pushing the same direction, which means that I don't care if you choose positive or negative, you're adding two numbers up, you get a bigger number. 27 and 30 gives you 50. Both are going east, so the answer is, I'm sorry, not 50, 57. So the answer is 57 newtons east. Cool? Alright. Below all that, back on the front side of your notes, you have this big word flash across there. It says inertia. And there's a definition of inertia. The tendency of an object to resist all changes to its motion. Did you pause and write it down? Good. Here we go. One thing only controls inertia. Find a place to write this down. The only thing that controls the inertia of an object is its mass. More mass, more inertia. Less mass, less inertia. Nothing else controls inertia. Only mass. I could say it again, but do I really need to? No, I didn't think so. Okay, y'all got it, right? Good. All right. So, this will lead us to Newton's first law, also known as the law of inertia. And here it is. Pause, write it down, then I'll go over it in detail. An object in motion will stay in motion, and an object at rest will stay at rest until a net force acts on them. A net force, not balanced forces, a net force. Right now, the net force on you is 0. You're going to stay at rest. I'm assuming you're not jogging while you're watching this, so you're not in motion. You're at rest. Your motion is 0 meters per second. All right. If an object is moving, you have to put a force on it to get it to change how it's moving. Slow down, speed up, or turn. Basically, objects do not want to change their velocity, how they're moving, ever. To get them to change the velocity, you need a net force acting on the object. That's a summary or an explanation of Newton's first law, law of inertia. Okay, y'all done a lot now. Take a breather. Go get some hot tea, cocoa, coffee if you drink coffee, a sweet tea if that's the kind of person you are, whatever, it's all good. And then come back for the second PowerPoint and the second set of notes. Okay? Bye-bye.